Welcome to LazyPanda, a comfort mapping application for interior spaces. So I shall start by demonstrating the telemetry file and its connection to the MQTT and the database through our server. Now the telemetry file has started running. As you can see, our client has started being populated with the data. One of our beacons seems to have an error as it's getting extraordinarily high values, but for the other part it seems to be the same. This is the time 5:48 and 5:48. And the database was initially empty, and now that the telemetry file is running, it's populated with the information regarding the 4 beacons. And we don't have excessive entries because we just update each of the previous entry with the latest value, because that's what we are using in our calculations. As a result of us not being able to integrate Cordova Ionic with our functionalities, part of it is on the web page and part of it is on the Ionic and Cordova application on the mobile. So I shall start by demonstrating the first feature, which is setting our preferences. For example, I'm going to go with 28 in terms of temperature, and I want really low light, so I'm going to go with 5, and I set the preference. Once I set the preference, I'm able to view it on the Cordova application. By saying get chosen preferences. Yeah, and I'd gone with 28 and 5. I can also connect to the MQTT server from here and get the current position. And I'm using the current position to find my nearest beacon. While the beacons themselves have their geolocation hard-coded, our current location, however, is not. So we're using the law of Haversines to calculate the difference in latitudes and longitudes from our location and the hard-coded beacon values to find the nearest or the beacon that has our comfortable index. And as I've shown earlier, we have the user preferences. Now I can choose get data and see the values of all the other beacons, the beacon ID of the beacon that matches my comfort preference, and a simple routing instruction saying keep heading north or keep heading south, and so on, as we would get. And as I mentioned, since the difference in latitudes and longitudes are very similar in the small range of the beacons, we had to go with something like this instead of a more detailed route. Next, I shall proceed to demonstrate the next feature, which is the viewing of comfort maps. We have the options of viewing the temperature graph in general, the luminosity graph also in general, and the average index, which is based on some calculations of the temperature, luminosity, and your user preference. We have considered using PMV and PPD of thermal comfort calculations, but we didn't use all of it. We used some elements of it along with some simple arithmetic for this demo. And as you can see, the temperature graph are quite similar. Then here we have the luminosity. The beacon closest to the light has the highest value, and the average index based on your preference. So 2 of the beacons are close to what I wanted and 2 of them are not. In terms of system architecture, we have the beacons, and the beacons transmit information regarding the temperature, the light, and their unique ID. And this is gathered and published onto a MQTT server, which is Hive, as we're using under the topic LazyPanda, but the Raspberry Pi. The telemetry file runs on the Raspberry Pi, uploads it to the broker, and then our application server, which is using Node and Express, subscribes to this topic and gets the relevant information, updates it to the database with the most recent value. We're using CouchDB, and in terms of middleware, we're using Cordova and Ionic for the mobile application, and we're using plain HTML with some Angular and normal CSS for the website itself. And that's how our architecture works. This architecture can also be extended to wearables, nearables, home assistant systems such as Google Home and Alexa by following the standard Internet of Things architecture that we are following right now. We feel our application is relevant because comfort itself is a very subjective topic. For example, a person might find this place comfortable while another person find this place comfortable. So our application enables the user to set a profile and then work on it in such a way that when they enter a new space, they can choose a place that they find comfortable, and they base it on the parameters of temperature and light, which is what the BLE beacons provide. In the future, we could expand this to include functionality such as when a person goes through an area with BLE beacons, and if they're and the user has a profile on the account, and when they passes by an area with the beacon, it would alert them as to whether the zone is close to their comfort or not. We try to implement that functionality. However, due to our beacons not being proximity beacons and the transmission strength being not that reliable to calculate the proximity, it didn't really work out. So yes, that's why we believe that the comfort mapping has a lot of potential application. That brings us to the end of this demo. Thank you for watching and have a nice day.